Hi, ladies and gentlemen. Notes 4.3 are on simplifying algebraic expressions involving exponents. So if you notice the note that I have written down right here, it says we're going to apply all the rules that we know from our 1D course, or grade 9 math, and from notes 4.1 and 4.2 to simplify our algebraic expressions. So essentially, this lesson is just about pulling everything together. So it asks us to simplify SA of r over V of r, given that surface area of r is equal to 4 pi r squared and volume of r is 4/3 pi r cubed. And just a little note, just a reminder that these are the formulas for the surface area and volume of a sphere. So I want to know what the ratio is between the surface area and the volume of a sphere. So if I know the surface area is 4 pi r squared, that's going to go on top. Okay, and then I know that the volume is 4/3 pi r cubed, so that's going to go in the denominator. Okay, and I'm actually going to show you two different methods to approach this question, and then you can choose whichever one you feel more comfortable with when you're approaching similar questions. So first of all, I want to deal with my coefficients, and my coefficients are saying to take 4 and divide it by 4/3. But when I take 4 and divide it by 4/3, it's the same thing as taking 4 and multiplying it by 3/4. Remember, I do the reciprocal, which means these 4's can cancel out, so I end up getting just a 3. So that means that my coefficient is going to be plain and simply 3. And then when I divide, I should subtract my exponents. So if I've got pi to the power of 1 divided by pi to the power of 1, I end up getting pi to the power of 0. And then r to the power of 2 divided by r to the power of 3 gives me r to the power of -1. Okay, well, the 3 just stays a 3. Pi to the power of 0, anything raised to the power of 0, remember, is 1. So it's 3 times 1. And then r to the power of -1 means 1 over r. And this technically is all over 1. So when I multiply everything through, 3 times 1 times 1 is 3. 1 times r is r. So when I simplify it, it's 3 over r. But I want to show it to you in a slightly different way as well, so you can choose the method that you prefer. The first part is exactly the same. I'm still going to take 4, divide it by 4/3, and I end up getting 3. Okay? Then I can say, well, my pi's are both pi's. They're exactly the same, so they can cancel each other out. Then I can also say, well, if I have r to the power of 2 here and r to the power of 3 here, 2 of my r's are going to cancel out, and I'm going to have an r left over. And the r that's left over is in my denominator. So I end up getting 3 over r. Right, so we want to simplify some of these examples that we have here. So if you notice right here, we have all of what we have in our numerator raised to the power of 3. And this 2 has an invisible exponent of 1. So what I'm going to do is I'm going to raise everything to the power of 3. And when we have a power raised to a power, we multiply our exponents. So we end up getting in our numerator 2 to the power of 1 times 3 is 3. Okay, x to the power of -3 times 3 is -9, and then y to the power of 2 times 3 is 6. All right, and then in my denominator, same thing with my exponent of 2. I want to multiply everything in the brackets with that exponent of 2. So I end up getting x to the power of, multiply those exponents, 3 times 2 is 6, and multiply these exponents, -4 times 2 is -8. Okay, so I want to actually evaluate my coefficient. So 2 to the power of 3 is 2 times 2 times 2, which is 8. So I get 8x to the power of -9, y to the power of 6, over x to the power of 6, y to the power of -8. Now that I've done that, there are two different ways that we can approach this problem from here. So I want to show you both ways. So the next thing I'm going to do is just use my my exponent rules for my integer exponents, because my exponents are integers here. So I'm going to keep my coefficient of 8, but when I divide, I need to subtract my exponents. So for x, what I'm doing is -9 as my exponent up here, minus my exponent of 6 in the denominator, so I get -15. So I end up getting 8x to the power of -15, and then for my y's right here, I have 6 as my exponent in the numerator, and I'm subtracting an exponent of -8. So it's 6 minus -8, but minus a negative turns into a positive, so it's just 6 plus 8, which is 14. So I get 8x to the power of -15, y to the power of 14. Now, one thing I want you guys to be aware of is if I have a negative exponent, it just needs to go where it wasn't originally. So this is technically over 1, okay? So this 8 has no negative exponent, so it stays where it is. This x to the power of -15 has a negative exponent, so I technically want to do the reciprocal of it, but if a shortcut is, if it's in the numerator, I can just put it right in the denominator and make it the opposite sign. And then y to the power of 14 is not a negative exponent, so I don't need to change its location, so I can keep it there. And this is my simplified answer without any negative exponents. Okay? Another option that you have is to just simply move everything first where it belongs and then go ahead and simplify. So what I mean by that is as follows. This 8 should stay where it is because the exponent is positive. The x to the power of -9, so actually let me color code this so you can kind of see it a little bit better. I'm going to do the numerator, what was originally in the numerator in red. So x to the power of -9 is in the numerator, but because the exponent is negative, I'm going to now put it in the denominator and make it a positive exponent. Then y to the power of 6 is positive. The exponent is positive, so I'm going to keep it where it was. So I'm going to keep this y to the power of 6 in the numerator because that's where it originally was. Okay? Then I'm going to do the denominator part with purple right here. So in the denominator, I have x to the power of 6. Since my exponent is positive, I keep it where it is. And since this exponent is negative, I'm going to change where it is. So it was originally in the denominator. When I do the reciprocal of it, it's now going to move into the numerator. Okay, now that I've done that, I can just multiply anything that have like bases. So the 8 stays the same. There's 2 y bases here, so I can multiply these guys together. And when I multiply, I would add my exponents, and 6 plus 8 is 14. That's what I got up here. And then down here, I have same bases, and I'm multiplying, so I can add my exponents, and I get 15 in my numerator, or sorry, my denominator. So either way, I'll get the same answer. All right, in our next example, this one's a little bit different. So here it's multiplication, and since it's multiplication, I need to add my exponents. So when I add my exponents here, this would become x to the power of 2n plus 1 plus 3n minus 1 all over x to the power of 2n minus 5. Okay, so I end up getting x to the power of, well, 2n plus 3n is 5n, and 1 plus -1 cancels out, so I just get 5n in my numerator, okay, all over x to the power of 2n minus 5. Well, that ends up being x to the power of, I need to subtract my exponents, so it becomes 5n minus 2n minus 5. But I have to distribute that negative, so it technically becomes x to the power of 5n. This negative, when I distribute it, I get minus 2n, and then I get plus 5. So I end up getting x to the power of 5n minus 2n is 3n, so I get x to the power of 3n plus 5. Okay? All right, guys, 2 more examples, and then we'll be done. So in the first example that we had in number 2 right here, we had integer exponents. Then we had variable exponents. Now we're going to talk about what happens with rational exponents, but it's pretty much the same idea. So just like we did up here, we want to raise our power to a power for all of our exponents because everything is being raised to the power of 1/3 or to the power of 1/2. So again, invisible 1, invisible 1 for my exponents for my coefficients. So I'm going to go ahead and evaluate my numerator. I'm going to get started evaluating it. So remember, when I have a power raised to a power, I want to multiply my exponents. So 1 times 1/3 is just 1/3. So this becomes 27 to the 1/3 power. And then -3 times 1/3, is -1. So I end up getting a to the power of -1 because -3/1 times 1/3, these 3's cancel out, so I end up getting -1. Then, if I do b to the power of 12 raised to the power of 1/3, I multiply my exponents again. So 12 times 1/3 is just 4. So I get b to the power of 4. Okay? And then in my denominator here, I end up getting 16 to the power of 1/2. Okay, and then I get a to the power of -4 because 1/2 of -8 is -4. So -8 times 1/2 is -4. And then 12 times 1/2 ends up being 6, or half of 12 is 6, right? So it's b to the power of 6. All right, so next thing I'm going to do is I'm going to evaluate my coefficients. So 27 to the power of 1/3 just means take the cube root of 27, so I end up getting 3, okay? And then 16 to the power of 1/2 means to take the square root of 16, so I end up getting 4, okay? And then the rest of it I'm going to leave as is, a to the power of -1, b to the power of 4, and then in my denominator, a to the power of -4, b to the power of 6. And I'm going to do this 2 different ways just like we did before. So the first way I'm going to do it is just leave my coefficient as 3/4 because that's essentially what this is saying. And then when I divide, I should subtract my exponents. So it ends up being -1 for a minus -4, but minus a negative turns into a positive, so -1 plus 4 is 3. So I get a to the power of 3. Then I'm going to do the same thing for my b's, and it's 4 on top minus 6 on the bottom, so 4 minus 6 is -2, so I get b to the power of -2. Now, lastly, I'm going to put everything where it belongs. So the 3 has a positive, is just 3. It technically has a positive exponent of 1, so I'm going to leave it in the numerator because that's where it was. The 4 is in the denominator. I'm going to leave it in the denominator. A to the power of 3 is positive, so I'm going to leave it where it belongs, and if it's technically over 1, so it stays in the numerator. And then b to the power of -2 is technically also over 1, so I'm going to reciprocate it, and it's going to now be in my denominator. So my answer is 3a cubed over 4b squared. Okay? The other option is to look at it like we talked about up here with this piece right here, placing everything where it belongs first and then going ahead and simplifying, okay? So I'm going to put all of my red values where they belong. So this 3 stays where it belongs because it has a positive exponent. A to the power of -1 was in the numerator. Because it's a negative exponent, it now needs to go into the opposite spot and become a to the power of +1. And then b to the power of 4 is a positive exponent, so it stays where it belongs, okay? And then the 4 right here stays where it belongs because it's just a positive exponent. A to the power of -4 should not be where it is because it's a negative exponent, so we're now going to put it in the numerator. Okay, and then we're going to keep the b to the power of 6 in the denominator. Okay, we're almost done. The last thing I need to do is just simplify it. So the 3 and the 4 stay where they belong. Okay, and then if I've got a to the power of 4 and a to the power of 1 here, this a will cancel out. This a to the power of 1 will cancel out, and I've got a cubed left over. So I've got a cubed left over in the numerator. Then if I've got b to the power of 4 and b to the power of 6, the b to the power of 4 will cancel out with a b to the power of 6 down here, and I'll have b squared left over, so I'll still get the same answer. Again, it's your choice, whichever method you feel most comfortable with. All right, lastly, our last example that we have here has radicals in it. So we want to convert our radicals into exponents, okay? So how do I do that? Well, in my numerator up here, I've got x to the power of 8, and I'm taking the 5th root of it. So that means that the 5 is going to be the denominator of my exponent, and this 8 up here is going to be the numerator. So it's x to the power of 8/5, okay? Because again, this is saying take the 5th root and then raise it to the power of 8, okay? And the order doesn't matter. So then here, what this is saying is I've got 3 in my numerator because that's the power right here, but I'm taking the square root, so I have to divide it by 2. And then the whole thing is being raised to the power of -3. Okay? But remember, when we have division, we have to subtract our exponents. So I'm going to do my work on the bottom right here. So it's 8/5 minus 3/2. Well, my common denominator is going to be 10. So I'm going to multiply 5 by 2 and 8 by 2, and I get 16 over 10, okay, because I want 10 as my denominator. And here I'm going to multiply the 2 by 5 to get the 10 that I want. So 3 times 5 is 15. So when I subtract it, now that they have a common denominator, I get 1/10. So what this ends up being is x to the power of 1/10 all raised to the power of -3. Well, when I have a power raised to power, I just multiply my exponents. So I'm going to take 1/10 and multiply it by -3 over 1. So I get -3 over 10. So that means I get x to the power of -3/10. But if I have a negative exponent, I need to do the reciprocal. So I end up getting 1 over x to the power of 3/10. Well, 1 to the power of 3/10 is just 1, okay? And then I end up getting x to the power of 3/10. So you know what? We'll write 1 to the power of 3/10 over x to the power of 3/10 over here. So I end up getting, well, 1 to the power of 3/10 is just 1. And then x to the power of 3/10 means I'm taking the 10th root right here, because that's in my denominator, of x raised to the power of 3. And that's my fully simplified answer. Let me know if you have any questions, and I'll see you next class. Have a great day.